Hi, today we'll be talking about the physics of martial arts. Allow me to begin with a basic lesson in the differences between the different styles of martial arts. Through the years, the martial arts have been refined and changed from the way they were originally taught. Many of these refinements are due to the basic kinematic and energetic physical principles. The movements have been broken down to increase their efficiency in much the same manner as we would break down the inner workings of a semiconductor or car engine or circuit in order to improve their efficiency. Now, the martial arts can be separated into two extremely generalized styles, hard style and soft style. Hard style martial arts incorporates the use of punches, kicks, elbows, knees, and other hard strikes and blocks for the effect of crushing and destroying the body of their opponents. Soft style, on the other hand, uses joint blocks, throws, takedowns to cause extreme pain to the end for their opponent. So let's start with the basics, as I've written right here, as I'm trying to also get a line. Okay, let's start with the basics. So we can begin to analyze the martial arts with some of the basic physics knowledge that we attained during high school. Then, after that, we can begin to incorporate more and see how the problem can become a bit more complex. So starting with our basic equation for energy, we can write out an equation that will give us a fair understanding of what goes into the simplest punch or block. So first, let's analyze a basic straight punch. A martial artist punches in a way to maximize pressure by using only a surface of the weapon 1 inch by 1 inch max. Many martial artists use a rotating fist in order to help align the two punching knuckles appropriately. But we will take our first punch to be more of a kung fu style punch where the fist is held at all times with the knuckles vertical to the surface of the earth if the attacker is standing, as you can see in this picture right here. And I will explain later why there are lines on it. So using the concept of physics, we can use the concept of kinetic energy, which is based on mass and velocity, and also we can use potential energy, which is based on mass, gravity, and a change in the position in the vertical, which would become y. We can write the following equation using this information, which would be E equals 1 over 2 mv squared plus mgy, and I just said why this y is here, and there's a y over here as well. This y is there because there's a change in the position in the vertical. Anyways, let me explain what this equation is. This equation is where m is the mass of the fist and the arm, which would be approximately around 7 to 10 kilograms, and v is the velocity in the horizontal direction only. Now, taking the velocity to be the velocity of the arm and the fist at full extension, we can certainly say that the total mechanical energy of the punch is just prior to contact with the target. Now, once we have this total mechanical energy, we can use it to find the amount of pressure being put into the target due to the amount of area of the punch and the force due to the energy of the punch. But first, of course, we need to find the force of this punch, which we can use Newton's second law, which is F equals ma. Now, obviously, when we get this F equals ma, when we get the force, it is going to be a large number because it's going to be the whole arm from the shoulder going to the fist. So this would be an obviously very large number. But we must understand that the entire arm did not travel the full distance. We can make a correction where we sum the distance traveled by each part of the arm over slightly less distance as we get closer to the shoulder. And now, as I said, I'm going to explain why there are the pieces of the lines in the arm. It's because we chop this arm into 10 pieces, and each piece being the 1/10 the mass of the whole arm, and then take each piece that has traveled 1/10 less than the piece just further from the shoulder, and then we can easily just tell what the force is, and we won't get such a big number that we're going to have a problem with, or it's going to give us the wrong answer. Now, after when we do all that, now we can find the pressure created on the target by the punching hand by using this formula right here, or equation right here, which is pressure equals F over A, F being force, of course, which we can attain through, through here like that. That's a great arrow. I love that. What the hell? There we go. So, anyways, F would be the force, and then let me explain how we get A. Even from this simple model, we can use physics to determine the destructive power of martial arts. But sometimes someone might think that it's difficult to find the area of a fist, heel, or foot, because on each unique person, these areas will be completely different. And quite significantly, in many cases, it is. In martial arts, however, the use of the 1-inch rule is a well-known, widely used rule for the weapons of the hand, feet, legs, and arms, and etc. Now, the 1-inch rule states that any weapon used to attack or block should be no wider than 1 inch at its widest point. We use the index and the middle finger knuckle on the fist only, and these are approximately 1 inch apart on any adult. There are 7 primary weapons on the hand, each of which is approximately 1 inch in width at its widest part. Using this information, we can easily suggest that the punch weapon is 1 inch square, and changing that into centimeters gives us 6.45 centimeters square. So when we submit all that into this equation, we already have our force from the last section that we just talked about. So when we have the force, we got the force, and then we're going to get the A, which would be 6.45, and then we're going to convert that into meters, and then it'll be meters squared. After that, when we divide these two, we get an answer, which would be for P. This is that's the temp for P, which would equal whatever the number would be. And then after that, we get the pressure. Now we will add a few factors to the equation and look at how the problem can first become more involved, and second, give us a much better idea of the true power behind martial arts. Now in the next part, I will be talking about the effects of rotational mechanics. That would be if someone was about to use the soft technique of martial arts, and throw someone or put them in a joint lock, but mostly it's about takedowns. So this will be more about the CQC, close quarter combat takedown, where the person will grab someone and throw them over their body, and that would be called the effects of rotational mechanics.